Good evening, everyone. It's with great pleasure that I'm able to welcome Kas Oosterhuis as our CCA architecture lecturer this evening. Tonight's lecture is part of a special series of events called Seeing Orange, Dutch Design Week at CCA. All of the events are listed on postcards that we have that are by the entrance to the lecture hall. And I just also want to announce that tomorrow evening that there will be a kickoff event, reception and exhibition at the New Black, which is at 1999 Bryant Street. It's Bryant and 18th. That'll run from 6 to 9 p.m., to which you're all invited in San Francisco. Dutch Design Week is being co-sponsored by the Consulate General of the Netherlands, and I want to thank them and Jennifer Cattell and her colleagues for all of their support, for working with us to form a stronger cultural global partnership to enable events such as this one this evening. We've been doing this now for a few years, and we've been able to bring a number of Dutch architects and designers to CCA and have events throughout the city. Kas is a professor of architecture at Delft University, as well as the director of Hyperbody and the Protospace Laboratory for Collective Design and Engineering. His research and teaching has been focused in the areas of interactive architecture and the real-time behavior of buildings and environments, the concept of living buildings, as well as parametric design and file-to-factory production. His firm, initially established in 1989 in Rotterdam, was later renamed ONL for Oosterhuis Lénárd, in partnership with Hungarian visual artist Ilona Lénárd, who's with us this evening as well. The work of the firm and the experimental nature of Kas's research pushes the boundaries in many ways of typical design practice in the Netherlands. In his most recent book, Towards a Kind of New Building, Towards a New Kind of Building, A Designer's Guide to Non-Standard Architecture, published by the NAI in 2011, Kas speaks to the paradigm shift from the standard to the non-standard and the shift from static to dynamic forms of architecture. The firm's works have received many honors and awards and have included such notable projects as the streamlined and whale-like CET project in Budapest that received an Autodesk BIM Experience Award, and the earlier Hydra Saltwater Pavilion that received a Gold Award for innovative recreational projects and a nomination for the Mies van der Rohe Award. The latter building was one of the first contemporary projects exploring the physical and perceptual conditions of fluid space and the dynamics of an internal sensory experience, and was part of the complex at the Delta Works in the Netherlands that was done in concert with the Freshwater Pavilion by Knox Architects. Other projects have included the Liwa Tower project in Dubai that synthesizes architectural form, structure, and ornament through an elaboration of a slightly curved, perforated building skin. And the Hessen Cockpit Building and Acoustic Barrier projects in Utrecht and Vienna. The former was the recipient of a number of awards, including the National Steel and Glass Awards and the Dutch Design Award for Public Space. These projects are focused on transforming infrastructure into dynamic models for architectural parametric exploration and intervention. These and many other projects reveal the firm's interest not only in speculation, as one might project toward interactive design futures, but also a strong commitment to innovating with materials and technologies and embedding these within real contexts. Kas's research and design work and the work of the firm has been published extensively and exhibited internationally in many prominent venues, including the Pompidou Center in Paris, the FRAC in Orléans, the Venice and London Biennales, along with exhibitions in Shanghai, Beijing, Frankfurt, Munich, Brussels, Dubai, and many others. He is a graduate of Delft University of Technology, where he's a professor of digital design methods, along with directing the Hyperbody Research Group and the Protospace Lab. We're really happy to have Kas with us this evening to inaugurate our events as part of Dutch Design Week. Please join me in welcoming Kas Oosterhuis.
Well, thank you, Ayla. I'm wondering how much of your time how much endurance I can ask from you tonight. I prepared a lecture of, I think, more than 1 hour, so, but let's see. What I usually do in lectures is to have an interactive setting. That means that I usually have a second screen, and then you can send your tweets. And then I read the tweets, and I can respond what you are thinking. And it's a kind of interactivity I like. So I didn't set it up tonight, but if you want to say something while I'm lecturing, please do. Yeah? Please interrupt me, and please start the discussion while lecturing. I like that much better than having questions afterwards. So let's see if you have the guts. The new standard, it's almost a contradiction, because I'm not for standards, I'm against standards, because standards are actually built when there is a relation between two things, two people, or two situations. Then you build actually your own customized standard. So, but the new standard is meant to be that kind of standard, which is also referred to as non-standard, that actually includes all the other forms of standardism that has been around for the years. So the approach to try to have one standard that fits all is really the wrong approach. And I will show you that through our approach to building. You will hear from me a lot of words like these, but so I won't read this for you. But there are words that are completely new in architectural language. Some of them, or many of them, are included in this book. The main system of this book actually is 4 chapters. One is tag that body. Tag that body means that I see architecture as a body. I see buildings as a body, having a body, something that is consistent and integrated. And then I say, make that body, this is the 2nd chapter. How do you make things? So I think the construction methods, especially CNC construction methods, are purely essential to have in the design phase. And that's exactly what is missing in most of the buildings you see around, that they are designed. It's very linear process designed, and then they are tendered, and then they are taken apart, executed somehow, and it misses the integrity of the original design. But now we have the new tools, the CNC tools, and as designers we can be makers as well. So having the making in the design process becomes one of the most important features of today. To put our work in context, I can also have some points of critics on colleagues. This is OMA. So when OMA thinks they have to make variations, they have 100 students or trainees, and they make variations on one tower to reach this goal, to reach that. So is that parametric? No, it's not. It's just a waste of time and work, I think. So the way I would like to approach it is to have one system where I can tweak all the points, all the vertexes, just like it's also designed for a tower, exactly similar, with a completely different attitude. Then I write a program where I can tweak all these points. Probably because this came too close to this, but I'm not sure. I won't do that again. So I can tweak those points for all of these floors, and while tweaking, this is my target value. I need to make 20,650 square meters because that is what the project developer wants. Disappoint him. I want to give him exactly that. But I also have my freedom in tweaking these lines and all these points and having the curvatures. And I can exactly keep track of what I'm doing. So that process has led to this design, which is exactly 20,650 square meters. And the interesting thing here is also that in the process, things change. So for example, in 1 week before we had to submit for building permit, there was an extra elevator planned inside. So we had to pump up the whole volume again to reach the same GFA, because the elevator is not in the GFA. So we had to pump them and tweak all these curves again, and we did that whole work within 1 week. So we redesigned the whole design because it was a parametric system, because it was consistent, and all the parts were related to each other, we could do that. So this is important quality or potential of parametric design, that you can have all building components related to each other in every stage of the project, from sketch. Well, I cannot do any lecture without showing heroes. Well, this is one of the heroes. And you can see what he has in his mind. This kind of landscaping. He's here at the age of 100, I think. And well, then you can also see some other things. He has these curves, but these curves are not perfect. It's actually a rough technique that does not allow to have sketches, these sketches, directly translated into buildings. And that's what we try to do, and that's also very much in the way we work together, that we want to have intuitive approach, directly related to how things are made, with the precision of the new technology. Those examples, it's not an example of what we want to do, but it's an example of that intuition plays a big role in architecture, and they actually, in almost the same period as we started doing that, they also initiated that. So this was almost blind sketching, and then translated later, but not via CNC machines, but via a shipbuilder who could do that. Actually, we worked with the same shipbuilder later. What we did, actually quite before, or this is actually Ilona's work, sketching with the computer. So very fast, intuitive sketches leading to work, this is works of art, which are derived from those intuitive sketches. And that was fascinating, because there we had the speed of the computer, and we suddenly could relate to that very fast speed of the computer. We are very slow with our brains, but we suddenly could relate to that. And suddenly we could find a link between the computer and intuition, between intuition and logic. And of course, our steps, our first steps, were very small steps together. And finally, step by step, we went to that whole body, to actually manipulate the whole body based on intuitive gestures and acts. So this was our first project realized, and actually we wrapped a sketch around as to alienate, actually it's a 6 housing project, as to alienate it from its content. Because what we wanted to do, we want to clean the facade first, empty it completely, and then actually add another quality to it which has nothing to do with the function. And that was another important step we took. And of course it does function. You could slide doors open and put your car in there. So it was a very pleasant way of living, actually, in this patio housing in the middle of the city. So this is another example of those power lines, actually, that's how we call them, these intuitive gestures. They can constitute a building, eventually. So it's one gesture, and we already have in mind that it's becoming a tower, and that's becoming a bridge, and that's becoming a canopy-like structure for a bus station and a restaurant. So we already have that in mind, and we make the sketches, and then these sketches become exactly the basis, very precise, for the later building. Then we construct surfaces, and we pop a network or with points or what we do. This one has not been built. Another example of an intuitive sketch directly translated into a building. And actually the interesting thing is you can just do this. There's nothing which stands in the way to do this. You can just do it. Of course, we have to find a system how to build this, how to build components and how to connect components to each other. And of course, here's another system embedded in it. You have to think of that component and the others. How do they connect to each other? That kind of for today's architecture, I think it's not so much the isolated things themselves, but how they connect to the other. I think that is some of the basic things we are worried about these days. The essence of how we operate. How we operate is very much like procedural work, procedural painting. So generating sketches is already a procedural act. And the way Ilona did it, for example, was making hundreds of sketches and in 1 or 2 seconds, very fast. So what Jackson Pollock was doing is also very procedural. It's a method. It's very methodology. And that is very, very interesting because it is so close to scripting. And scripting is something I will address later, which is then the technical basis for the procedure. And well, you keep on doing this, and it's very clear that these were very simple rules based on this system. It's very systemic. It's also very intuitive. And these two are interesting to join, systemic and intuitive. And so it's very simple in its rules, but in the end, it's complexity in its most essential form. So it's not complicated, it's complex. And that's the big difference I want to emphasize tonight. I don't like complicatedness. So, because it's a lot of work. And then, so if we refer back, for example, we just discussed a morphosis building. That is complicated. That's a lot of work because it's inconsistent in the way how different components relate to each other. They clashed more or less to each other instead of that they arise from each other. It's much different from this. Although you may say this is something like chaos, it looks chaotic. It's not. It's very procedural, it's very systemic, it's very controlled. Another control freak is Frank Stella. And well, we liked his work a lot. So in the 90s, early 90s, we looked a lot at this kind of work. Also, you see here in the textures, it's completely procedural. How these, these gestures are actually put on the aluminum here in this case, or there. It's even better to see. But he combined that with these ugly cones. And this, which I hate, because these are platonic volumes, and that's exactly what we don't like. But at the other hand, it had huge qualities because he painted into space. So, and that was another huge quality because painting was always flat. And now he painted into space. Yeah? Still on surfaces that were placed in space, but actually the idea was brilliant. And that's also why he called his book Working Space, by the way. It's this working space, enlarge, expand his working space of a painter. I think it's very important work. Another originating sketch from Ilona was the basis for a landscape design. Actually, we wanted to develop a large area, 7 to 9 kilometers. It's in Almere. It was on invitation to do an art project. It was not an architectural project. So we chose this as a site for actually procedural landscaping. On the basis, we needed a driver for it. So Ilona made many polynuclear sketches that had, in one gesture, had more centers. And then we mapped actually this, or you could say embossed it on the landscape, and the landscape in itself had these polder structures. All these plots were already there. And we gave them all a number, so it's a database, basically. And then, three-dimensionally, this sketch was pushing the landscape up, and other places it was actually bringing it down in a sort of ground balance, that no earth should come in. Then these plots start to develop into different colors, different functions. So it's a combination of the grid city, basically, like San Francisco or any American city. It's a combination of the grid city and a top-down act, a top-down gesture. The top-down is informing all these plots, but in a very specific way. And at the same time, there's this bottom-up grow from the grid city. So this balance between top-down and bottom-up became one of the major features of our work. So this was done in 1998. And also we introduced dimmable lighting, street lighting, that it's not always the same level, but actually you can play with it at lower levels, higher levels of lighting. And actually this was very much predicting LED lighting technology as of today, where we can exactly do that. So looking at colleagues, Winnie Maas and VRDV, this is what basically Winnie is doing with his legalization, so to say. He has thousands or millions of these Lego blocks, and the theme of him is porosity. So I want to actually position our work in relation to this by making two statements. His building block is always the housing unit, it's the block itself. Our building block is a building component, which is much smaller than that. Yeah? The other statement is, this always will remain low resolution because of that size of the building block, and it will never be able to expand the language into high resolution. Yes?
I'm just curious, you mentioned sort of like
Where are you? Oh, all the way there, yeah.
The gesture, the sort of intuitive sketch, kind of, it seems to me like, I'm just wondering what gives that privacy as a motivator?
Privacy?
Why do you start with just the gesture? What gives that its validity as a starting point for design?
Well, I have more examples of that. I need information. If you design a system, the system needs information from outside. Otherwise it doesn't live. So it feeds on information which is coming from outside. That is true for any human being. I mean, your brain feeds on information from outside. Otherwise you are well, veggie, yeah, so to say. You cannot do anything. So your brain is connected to all the other brains. That kind of relevance is always there. In any design system you have, you need information from outside. And this information actually drives the character, to a large extent, the character of such a system. The other part is bottom-up, what is emerging from the system itself. So these two forces we want to play with. And radicals, as Dutch designers always are, we radicalize everything. We do an extreme point of view of external information, which has nothing to do with logic, but has a lot to do with intuition. And this intuition we can feed into the system. And that idea I like very much, that it's not a logical idea that has to feed a logical system, an intuitive idea, so that we radicalized, so to say. The other important issue here is that we don't start with a function, but we make buildings that allow the building to function, which is a different point of view than that you start from it. It's open for functioning, but it's also open for something completely irrational. So, for example, in contrast to what the Y Factory at the university is doing, this is what our students are typically doing, but it's just one example. It has porosity, it has the same airiness that actually all architecture that is at the front, at the forefront of architecture, it's porous, it has a lot more air, and it's quite different from the agenda of sustainability, where you want to be as compact as possible and have as least connection to the outside. But actually, if you have a good quality of all these skids, you can do it. And then it's no longer an issue. And it's high resolution, so that's the other thing. So this is, for example, a sort of in-between step we are taking with our office. It's a climbing wall system. It's very systemic. It's open to information from for power lines from our side. It's open for interventions by climbers themselves. It's an open design system. It has the building components. It has a higher resolution than the living unit. And you can build anything with that. So that's actually the translation into practice of that attitude. So then we talk about resolution. So it's basically, this is an OMA project. It's again that low resolution attitude, which is very similar to what happened in the 60s and what happened in Montreal in also the 60s. As opposed, just to make clear, just to clarify positions, different positions you can take in architecture. So you can take either that position or you can take another position. This is one of our designs where we have a very high resolution actually in a roof. It's an underground project, and there it becomes a landscaping exhibition hall. And it's all based on that building component that actually can also become larger, and then it can shrink and expand. It's a complete parametric system, and it's completely moldable. That is higher resolution. As high as we think now it's feasible. You can also go higher in resolution, in fashion, for example, and you see a lot of developments actually in architecture that go even higher and higher in resolution. But there's a difference between fashion and architecture. So I suggest, as an architect, if you make models like this is 3D printed fashion, by the way. It's a Dutch designer, Iris van Herpen. So the representatives of Dutch consulate would be very familiar with this work. It's worldwide known. But it's different from architecture. So we should not make the mistake that this can be translated directly into architecture. But it's higher resolution. So this is a kind of resolution we are working with our hyperbody group in the TU Delft. This is a building block. It's fully parametric. It can take any shape, but it's always related to its neighbor. It's almost like, and that's the comparison I often make, it's almost like this is a bird, and that's another bird, and that's another bird, and together they work in a flock. And they always are measuring the neighbor. They always are, this reference point is always questioning that reference point here, which is the point of gravity. Where are you? What is your distance? And that is the kind of thinking we are completely immersed in these days. And I think that is a very good way forward for a next generation building to think like that. We have to change the very building blocks of architecture. That's basically the message. So don't think bricks, don't think prefabricated housing units, but think of building blocks that are fully parametric, fully controllable, both by your top-down design acts, radical or not, or by systemic emergence from the system itself.
I also use an approach like that, where maybe you have a series of points and they all relate to one another.
Yep.
But when the purpose of it is just to manifest a form that you sketched out, that's where I start to lose you, because I can see a purpose, a valuable purpose, being cutting down on material waste or creating some sort of unique lighting situation for a unique program. But when you instead stop looking at function and just make a parametric system to realize an intuitive sketch, that's where I start to kind of lose you.
Well, there's more to it. So stay with me. You will find out. There's more to it. Okay, the point I want to make here is that, okay, we have these swarming elements, but some elements may be a window, or some elements may be a ventilation unit. Some elements, well, not indicated here, but you have to imagine that. Some elements can be a heat or a cooling unit. So we can actually, and maybe that's already a sort of answer to your question, we can assign functions to each of those components. And all those functions together, they form a climate, a space, a building that functions according to a pre-requested program, etc. So that's how we can work with it. But whatever happens, the relations, and that is what actually I wanted to say, these relations must always be kept intact. Don't lose the connection. And that's, again, the connectivity point I want to make. It's always about connectivity, both in its meaning, in its construction, and in its functioning, its operational life. Okay, what you see here is the construction of that climbing wall. You see first reference lines. These reference lines are, the system is an open system. So what happens, for example, that some of those lines are curves that we like. Yeah? We as a designer think, okay, it has to be that. Other things you see is that there are sort of sloping things in the climbing wall that climbers like. So climbers like a challenge like this, like this. So that is the input of the climbers in this open system. So that's actually how we did it. We sit together with climbers. We have our own preferences for curves. We sit together and they may tweak the curves as well. They may tweak the model. So they become co-designers. It's an open design system. That's what I like. And then it has to be open to all sort of ends, yeah? All sort of threads where you can actually pull the strings and you weave all those strings together to make your project. Skin is an important issue, but not separate from structure. I will show you that. First, skin as such. Skin of the water pavilion. So it's new materials. It has a new quality of a skin. This is a very rough skin of the water pavilion. It's polyurethane. It's okay. Spend not too much time on each individual project. This is skin of a vase project that we did. It's a vase. You can put flowers in here. These are built-in tubes. You can put flowers in that soft body of the vase. So that's the soft skin. This is an electronic skin of the interior of the transport. Well, you should see it as a movie because everything can move. So these are fixed and these can move, these sizes. It's the aluminum skin of the TT monument that we made. So this is a 2 centimeter thick skin that is bearing all the loads and transferring all the weight to the ground. It's a shell structure, but it's a complete landscape. So if you zoom in on the monument, you see things like that. Another form of skin is this skin for the eye web, which is the second life of the web of North Holland. And then this is cold formed highlight, which is 2 millimeter thick. It's a very thin, it's almost paper. And then, well, weird details as to adjust all the different angles to the structure. But there's always a parametric relation between this component, the connector, and the main structure. Everything is in one system. So it's not like you see, for example, in a Gehry building, there you see, okay, you have the exterior wrapping, you have the interior plaster walls, and in between, a big space, you have somewhere a steel structure, which to Franco Gehry is completely irrelevant how that is designed. For us, it's completely relevant how that is designed because we want to have a parametric relationship between the structure and skin. It's not separate things. That's also why you cannot tender it separately. So as I said, we take very small steps, 1992, wrapping the volume with a dazzle painting. Later, it's not our work, this is in Linz. Later translated, these dazzle painting things are translated into electronic skins that are mapped, and you see that so often these days, that actually skins are mapped on a volume. So yesterday we saw, for example, the De Young Museum of Herzogenaurach. Basically, it's a very traditional building, how it's built, and then it's mapped with this copper, I think it is, this copper skin. This very nice, I must say, very nice skins, inward, outward, these punching, and sometimes with punched holes, very delicate detail, but it's basically a fashion. This is also a fashion. Very good designers from Austria, Meisel, and what's the other name? Difficult to remember, yeah. If you look at this, it's a great building. It's absolutely great space in here. But if you then look at the structure, so it looks as if I'm criticizing everyone. That's not the point. That's not why I'm saying this. It's actually pointing out that you can have a different attitude. You can choose your attitude, what you want to do. If you see this structure, it's a mess. I simply have to say, it's simply a mess. It can be anything. You see all sort of hybrid, even in the steel itself, all sort of hybrids, and then strange mixtures with the concrete. And somehow, this happens all the time. It happens to Zaha Hadid. It happens all the time. You see this fashion around it, and you see this very traditional structure inside. And even, which is weird, that this structure, which is absolutely able to bear its own load, it's supported by these. It's not right. And I'm absolutely sure that she doesn't really want this, but this happens if you don't integrate the way you structure it, you construct it into your design process. If you don't relate it in a way that it cannot be taken apart. Well, it's clear that it's like a drapery, like fashion, and that it's very difficult if you start like this, and that's another way it's actually for the person in the end. If you have this intuitive design approach, which Zaha Hadid obviously also has, if you don't connect it to your design system, how it's built up, Patrick's part, so to say, then if it's too loosely connected, you lose that connection between this skin and the structure that supports it. Okay, let's see how we try to do it. So all we do is we try to do what we think is right. And that's also typical Dutch, by the way. That's our... But, okay, I cannot change that. So, and it was orange too, but it tastes like lemon in this case. This is the cockpit structure. This structure is completely in sync with the skin. It's developed together, and if something had to change in the skin, some of the dimensions, for example, glass dimensions, you have to cut it in a certain way, and you cannot extend certain sizes. You have to change the structure as well. So everything is related to each other. And it's a building kit. It's IKEA. Basically, it's IKEA. You have some of these components. They're all different. So in that sense, it's not IKEA at all. So it's parametric IKEA. So you have all these components, and you bolt them together, and surprise, surprise, you get your building. It's that simple. And you can do it, well, you have these one-person offices. They can do it because it's that simple. If you build this relation properly, then you can bypass contractors. This building was not built by a contractor. It was built by a steel manufacturer. You can have a direct link between you and your design system and the one who makes it. And yes. Well, there's a lot to say about this, but that's It's also used for movies. It's a very nice space inside. It is a showroom for expensive cars, like Rolls-Royce and Bentleys, Lamborghinis. But now it's taken over by another guy, and he sells Lexus. I'm not sure that's the proper one. Okay, let's have a look at another aspect now. We have talking about these building components, the relevance of that, so I have more about that. But first of all, and that was the first chapter in the book, tag that body. So these are identities. All these points, it's a universe of the internet. All these points, they are tagged because your computer has an IP address, has a unique number. So what is now the case, that all of these components your building is constituted of, they need this unique number throughout the whole process. Chapters of a book, they have this unique number, and they have this unique relations to others. But this is maybe more interesting, and it refers to that hyperbody project I showed you of this building component. So think of all these players. You have these, they are similar, but then you have the other type. Here, these, the bigger ones. And they all have their functions, but together they form a relationship. Together they form interacting swarms of different components. That's exactly what they do. And then you have this type, and then you have the people that walk. It's all mixed. Well, of course, this is Bombay. It's all mixed. That is how it works. But it's fantastic. And this idea of interacting swarms of building components would be interesting to investigate for future projects, for the next generation building. And then look at birds, for example. This is what you know about a swarm of birds. This is actually the typical image. But this is more relevant, I think. This is also the swarm of birds. It's the same swarm. But they are informed by this power line. So that's another answer to your question. So how weird is this? How irrational is this? Why would these birds forming the swarm suddenly sit on that power line? It's exactly as irrational as this digital or intuitive sketch that is informing the design system. There's no difference. You got that? Or
that looks pretty nice to me. Yeah. It's a system at rest. But the previous picture, I would argue that's highly inefficient. It's multiple swarms that conflict with one another and ends up creating a situation that is...
But it works.
Just terrible.
It works.
Yeah, maybe not a bird.
Have you been in Bombay?
Well, this looks nice.
Yeah. Well, you are the order guy. Yeah.
Sure, right. Yeah, right.
Yes, slowly it went. Okay. This is the acoustic barrier. So we have, no. This is the cockpit. Back to the acoustic barrier. First we have this swarm, but they are already nicely aligned with the power lines that are imposed on the system. So then we have these aligned points, which are the bursts, and then we can run our scripts. We can run our scripts that exactly describe where these points are, what their relations with the neighboring points are. And from those points, we develop the detail. Then we expand the point with all sorts of sub-points, subsets of points that actually, in the end, describe the detail. So this is how we did it with the cockpit in Pro Engineer, another program. We have all these points actually driven by a mother curve, a law curve, so to say. So there is some sort of law and order here, but it's radical, it's irrational. It's driven by that. So we have all these numbers, all these points, and related in this network. And, oh, I don't have the next image here. Okay. I have to change the story then into this project. Yeah, that's I'm so tired of these linear presentations because I want to jump, and I cannot jump in this PowerPoint presentation. So, okay, this is all the data you need to build it, and driven by what I already said. You're driven the angles by the climbers and the curves by the designers. But this is about the scripting part.